All right, so recording started. So like I was saying, this is a second review session for the week. Hello, Sam. This is a second review session for the week. This is our last official session for the course this semester. There's going to be office hours from the TA and myself, still between now and the final exam. So if you want to come to office hours, for example, at 7 p.m., 7 to 8 p.m., I will have a session. What we are going to do is we are going to resume where we left off in that fake exam. So I have here the code that we developed together last time. I just slapped a 2 at the end of the file name so that you'll have like the first half on Canvas, and then when we're done with this session, I will upload the second half on Canvas, and at that point you'll be able to run it and play with it and stuff like that. Before we get started, I should provide the same disclaimer that I provided to your classmates this morning. I've been sick since yesterday, so I had a feeling that this would affect a little bit my live coding. It did. This morning was fun. A lot of cut and paste and little typos here and there. So we're going to see if it's going to be better or worse this afternoon, but I wanted you to have a heads up pretty much on the situation here. All right, well, with all the disclaimers and warning done up front, let's jump in. So here's our code. So what were we doing? Just real quick summary, okay? We had a main method. That main method set a variable to hold the name of a default log file. So we are going to use it today, okay? Today is going to be about file I/O exceptions a little bit, and then finishing up, the logic pretty much of our main classes. So we had this log file name here somewhere. We created an object of class series of transform, which is a container, right? And it contains what? It contains a bunch of objects that represent transformation that we apply on strings, okay? So we can, at some point, after we validate that the chain makes sense, we can call sot.apply or sot.undo, and it's going to feed that string, the string that we pass as parameter, through all of those transformation one after the other. So apply is going to be going from the first transformation to the last, and undo is going to go from the last to the first. Okay, and for each of them, we are going to call, depending on whether we do an apply or an undo, we are going to call apply or undo the methods inside each of those objects. Okay. All right. So that was our main setup. Series of transform inherited from array list of string transform. So string transform, remind you, is our superclass, and we have two subclasses of string transform. Let's look at them there: letter transform and reverse transform. Okay. So series of transform extends array list of string transform. We already wrote a little bit of code last time. We went further actually than the morning session. So we add code for validate. So we went through the whole list and we made sure that we had, we made sure that we didn't have an even number of reverse transform objects. So we used instance of to detect that. And if we did have an even number, we displayed just a little warning like this. So that was validate. And then we finished up with apply and undo. Yeah, question in the chat? Before we start, can we go over what the jobs of the apply and undo method are again? Absolutely. Jump in anytime when you have question. Okay, the point is not to rush to the end. The point is to make sure as many people as possible are reaching the end and feeling confident after this. Okay. So yes, we can go over the apply and undo method jobs. So we are in the series of transforms. What did we call it? Series of transforms class. Okay. So the series of transform class, sorry for the scrolling back and forth, is pretty much an array list. An array list of string transform, which means it can contain object of class string transform or reverse transform or letter transform. We're using polymorphism. Okay. So the job of apply is we are going to iterate and we're going to go over every one of those transform objects, one after the other. Okay. So this is what we're doing here. For each string transform st inside of this represents the array list. Okay, and then for each of them we apply their transform. So the first thing that's confusing to some student is we have an apply method for the series of transform object. Okay, and what it does, it goes over every object in the array list and it applies again their method apply to the string that we have. Okay, so there are two levels of apply method. This is the apply method in the series of transformed array list, pretty much. Okay, so we go over every string transform object. We apply it to the string TMP. So at the beginning, TMP is input. And then we get the result out of the string transform object. So it would be easier if we could just write TMP equal st.apply, like if the apply method returned actually the result of the transformation. It's not structured like that. It's going to make it easier actually to log things the way it's structured. So we have to do it in a two-step process. Okay, but that we don't have to invent. The instructions are pretty much guiding us through getting this done that way. All right, and so every time we apply a transform st to the string TMP, we then replace TMP by the result of the transformation, and we feed it at the next iteration to the next string transform. Did I address your question, Andres? Let me know if it was okay as a recap or if we need to go into a little bit more details. And undo, same thing, but the loop goes from the end of the series of transform to the start instead of start to end. And then we call undo instead of apply inside each of the transform objects. All right. So I think this is where we stopped last time. Yes, we were done with, let me see, string transform. Oh no, we went even a little further. We started actually writing code for string transform as well. So let's dig into that. What is the transform doing? Is it rearranging the order of the object? So the transform, when you say the transform, you mean this, st, the object that is referred to by st? Okay, so it's good timing for your question because now what we're going to do is we're going to take a look at the class that defines the objects that are going to be referred to by st, the ones that are stored in the array list. So if I scroll down, the next class is string transform. And I forgot, but we already started modifying that one, writing that one as well. So the class string transform as, I'm skipping the attribute real quick, we'll come back to them. The class string transform as an apply method also, and it has an undo method also. And string transform by itself models the string transformation that we want to apply. So when I call the apply method, I'm going to modify the string s that's given to me, and I'm going to store the result in an attribute named result. So the input will be just the string that you gave me. Result will be the string after it's modified. And for this class, for this particular class, our super class, what I said last time is that we are going to implement a neutral transform. Okay, we are going to implement the most elementary, rudimentary, stupid, if you want to call it that, string transformation that we could ever design. It's a transformation that takes a string as input and spits it out unchanged as output. Okay, so that's why here what I do in apply is you give me a string s, I assign s to my attribute input, I assign s to my attribute result. So I already pretty much performed the transformation. There was none. Okay, I just stored the input is the same than the output pretty much. And I mentioned that the main reason for which we implement this, because this is a transformation that does nothing. Why do we even bother, implementing code that does nothing? Well, it's because it still do something. Okay, here record log data is called every time you try to apply this transformation object to a string s. So this little method is going to keep track of what's happening and use a timestamp to keep track of when a specific apply operation was done, actually was performed. Okay, Same thing for the undo. So if anything, the apply method and the undo method in this class, what they are doing is bookkeeping. Okay, they are keeping track of, oh, you try to apply our transformation to this string at this time on this date. Okay, same thing, you try to undo it later on this time, this date, and on this specific string. And that's going to be how we're going to be able to generate a log file. So we kind of have those little spy calls here, calling the method record log data that we're going to scroll down to in a second, okay? And that allows us to actually record everything we need to later dump into a log file. Let's scroll back down. We didn't have time to get results, so we're going to do that now. But this is pretty much where we stopped last time. The only thing that I skipped over was at the beginning of the class. Oops, sorry about that. Let me undo this real quick. At the beginning of the class, we had a few attributes. I think I erased record log data here. I'm going to record it real quick. There we go. So at the beginning of the class, we had a few attributes here that we started defining: result and input. So you've seen how we use them. Okay, input is pretty much whatever string you want to apply the transformation to. Result is the result of applying the transformation to that string. There are a few more attributes. So let's get rid of them first. I mean, this is always an easy way to get code done and to get some points. Okay, so input, result, we took care of them already. We need an attribute named log file, and that attribute log file is going to just store the name of the log file that we are going to use later to dump all of our information. Okay, so that's going to be relatively easy to declare. It's going to be a string as well. We're going to make it private as well. So private string result, private string input, private string log file. And actually, and I have to decide if I'm going to spell it like this or with a lowercase f, because this morning I kept going back and forth. So let's do it with an uppercase f, log file. So this morning also somebody mentioned that if you read carefully the instruction, I wrote them carefully, but apparently I don't read them carefully afterward. If you read carefully the instruction, you are going to notice that all the attributes need to be private except result. And result needs to be protected. So right now it didn't matter because I still have not written any of the subclasses, okay? As soon as we start writing the subclass, later transform, reverse transform, then it's going to start mattering, okay? So let's get rid of it right now. Let's switch it from private to protected, so that will be done when we need it. And then the last field that we need, private date, and it's going to be called time stamp. And I'm going to try to be consistent with my canal case notation and use an uppercase S for timestamp. Okay. Would a super.apply or .undo and sending it a string work too? So in what context? Like, let me scroll where I think you want to insert that. In this context here, super.apply or super.undo would not work because we don't have like a superclass that's relevant that features those methods. When you are dealing with a subclass, which we are going to be dealing with like in a few minutes, then yes, absolutely, that's what we are going to do. We are going to override the apply method. We're going to override the undo method. And we are going to override with chaining, meaning that the overridden version is going to call back to the original version, get it to do its job. So you see, this is a way for us to have a base class that represents the most trivial transformation, but still does its bookkeeping. And then when we extend that class, that base class, we are going to create transformations that are more relevant, that actually do something, but we won't have to rewrite the bookkeeping code. It's all going to be already all integrated in the superclass. We'd send a super.apply what the result was. Yeah, you can do that. We are going to do that, but not in this class, not yet. Okay. All right. So back to the attributes. I think we are good here. We are going to save this, build it, and make sure that we have all the imports that we did. For example, for date, I think I did an import java.util.star. So if I did that, then yes, definitely we have everything we need, including date. So that's it for the attributes of this class. So once again, we are in string transform. We have 4 attributes. Now we're going to talk a little about constructor. So we had to add a constructor that was a 1R constructor just to make the compiler happy. But let's take a look at the instruction actually, because they need us to do a little bit more than that. So there has to be a 1R constructor that takes a string, and that string represents the log file name. Okay, we are supposed to use it to initialize the attribute log file. And then we initialize also every other thing that we have to initialize in this class. So that means input, result, and timestamp. Okay, these are like the 3 other attributes. So let's go. Let's jump through it and do it. So des.log file, again, the des here, I don't need it. Okay, just want to make that clear. I'm just using it because it's an easy way to mark an attribute, to distinguish an attribute. Okay. So des.log file equals log. Des.input equals, well, I'm going to put an empty string. The instruction asks me to put an empty string literal in it. Des.result, I'm going to also put an empty string literal in it. And then what I have left is a timestamp. So des.timestamp equals. So we're not going to create a date object right now because we don't want to record the time at which the object is created. We want to record the time at which we applied and or we undid, a transformation. So for now, when you don't have an object to store in a reference variable, you just assign the value null, and that's it. Okay, so that's the timestamp equal null. All right. So that's my constructor. I need another constructor. I need a no-arg constructor that will appropriately chain to the above. So you've seen that in plenty of IEs and almost all of our previous IEs since we started chaining constructors. By default, yes, you have to always appropriately chain constructor. If you can chain them, chain them. If you cannot chain them, then you need to have a good reason to have redundant code, okay? So in this case here, the instruction is going to tell you just chain the constructor, okay? We are going to have no parameter at all, so we are going to have to make up our own log file name. And the instruction tells us, if you don't have a log file name given to you, use empty string. So let's go for it. Here we go, public string transform. This time takes no parameter. Okay, so what I want to do is I want to do the same thing than here. So all of this, okay, except that the log file is going to be empty string. So I could write it like that. Again, this is not proper chaining. This is not the most economical way to write this stuff. If I want to write this economically, I'm going to just say I'm going to chain to another constructor of the same class. So not using super yet, okay, not chaining to any superclass constructor. The superclass for this class is irrelevant. I'm going to chain to another constructor that is in the same class. So here it is. It takes a string. I'm going to pass a string. And by passing empty string, I'm just setting pretty much the name of the log file to empty string, okay? And we are going to see that down the road, this is going to have interesting consequences, okay? Meaning that if you give me an actual log file and I can open it to write in it, I'm going to output all of my log information into that text file. If you give me something like an empty string, I cannot open a file whose name is empty string, okay? So that's going to fail. Or if you give me the name of a file that I cannot access or something like that, I don't have permission to write, blah, 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 then we are going to output all the log information instead to the console. So it's kind of a little different, slightly different take on exception. It's still, we are using exception for error handling, okay? The only thing that we're doing here that is a little better than what we have done in other previous example is that we have a real goal here. That is, if we cannot write to the file system for whatever reason, then our log is going to go to the console instead. So that's a good illustration of how exception can allow you to have a program that is resilient to error condition and keeps working and trying to do the best it can, under whatever circumstances, okay? All right, so we have our attribute, we have our two constructors. I think that's it, right? Yep, that's it. We needed only two constructors. Let's build. Make sure I don't introduce typos everywhere. Again, next one, apply. We already wrote that last time. We discussed about what it was doing. Undo, same thing. So these are like, okay. And now we're going to move on to the next method that we didn't touch on all last time, which is get result. So get result, it looks like an accessor, okay? It is. So get result is going to return the value of the attribute result, okay? So that part is simple, but we are going to do something additional, okay? So hold on, before I move on, let me catch up with the chat. Invalid method declaration, return type required public string transform. So I see a R and an O that have been switched around. So that would be enough for the compiler to say this is not the name of a constructor. And if it's not the name of a constructor, then you need to provide me with a return data type. This is the logic. So if you fix that FROM into a FORM, then the compiler should let you go. Yep, no problem. Trust me, check the video this morning. I spent an entire morning doing typo like that. And actually, most programmers, we do this, okay? We do like little typo like that, but that's why we compile frenetically all the time, so that we don't have to dig through 50 lines of code, you know, to figure out where is the typo that we cannot see every time we read the code. So that's perfectly normal. So get result, I was saying, is going to be an accessor that returns the value of the attribute result, okay? But it's going to do a little bit more than that. So what is that a little bit more part? Well, it's going to consider that when you want to know the result of applying a transform, this is when, I'm going to write any log information that I have into the log file. So I have a method to do that. The method name is write log data, I think. Let me double check. Yes, write log data. So when I call write log data, it's going to check the attribute timestamp, the attribute input, the attribute result, and it's going to format all of this information neatly and put it into the file. So this is where I'm going to do my file IO and also my handling of exception related to file IO, okay? But it's going to be triggered every time somebody says, okay, I applied or undid, you know, this transform on this particular string. Now I want to see the result. This is what triggers writing the log information. That's it for this method. So the instruction, we're kind of like guiding us through that. Next method is going to be a little bit more work, but it's simple. Next method, record log data. So we just used that method actually. We used it here. So there is the act of recording log data, which means you store in the attribute input, result, and timestamp the relevant information. You update those attributes. And then there's the operation consisting in writing this log data to the file, okay, or the console. These are two distinct operations. So here we are talking about pretty much setting our attribute so they reflect the current operation that we already perform or we are about to perform. Okay, that's going to be easy. The instruction guide us again through this. So there is a little bit of flavor text here to explain what I just said. But then the concrete stuff that we have to do is assign the input attribute to the string on which the operation was applied. So this is a string that's given to me. This is a string on which I'm going to apply my operation. Okay, so I'm going to say this dot input equal input. All right. The second one says assign to the result attribute the result of the operation. So in this case here, I have not performed the operation yet. So I'm going to say by default, the input is also the output. And then other part of the code are going to actually do something and modify that. We're going to see that more specifically when we reach the subclasses, okay? And then what else do we have left? We have left this attribute that represents the timestamp, okay? So be it. Let's go this.timestamp equal. And now we want to timestamp the operation. Now we want to create a record that's going to contain the information about what day is it, what date is it, what time is it, okay? So we've seen how to do that in previous IEs. We create an object, exactly, Andres. Yeah, we create an object of the class date, and that will do the trick just nicely. Okay. So again, a long description here, but really when you sort through the flavor text and remove it, there's really only 3 assignments to do in this method. The difficulty being in understanding pretty much how the methods work with one another. So you have to do a lot of back and forth. After that, this is going to get interesting. So you see that we have a lot more in terms of instruction. Now we are talking about the method that's actually going to write on this file for us. So the approach that we took, I'm going to summarize pretty much what the instructions are saying instead of reading them out loud. The approach that we took here is that every time you call write log data, you are going to reopen your file, write information into the file, close the file. Okay, so there could be like, I don't know, half an hour passing by, between when you write some log data and the next time you're going to write some log data. Fine, we're not going to keep the file open all the time. We just reopen it every time you have to write something in it. There's a problem with this. The problem is with what we studied in the lecture. If I try to create a print writer every time, the print writer by default is going to open a file for writing. And if there is already something in the file, it's going to be either an error, an exception, because the file already exists, or it's going to be overwrite the content. And I don't want either. Okay. The first time I'm going to write to that file, the file doesn't exist. I'm going to put my first log entry. Then the second time I call this method, I'm going to reopen the file for writing, and I want to put my second log entry at the end of the file. I want to append it at the end of the file. So to do that, we need to use a trick that we didn't cover in the slide, so it's given to you here in the instruction for that reason. You cannot just make it up and invent it yourself, right, from nothing. So we tell you here pretty much everything that I just explained, and we say if you want to open a file with a print writer and you want that file to be able to be appended information, then this is the syntax you need to use. How does it look? Well, print writer PW, yeah, we declare a reference variable of type print writer, no problem. New print writer, yeah, we did that. Okay, that's what we were doing before. But this is where the new stuff comes into play. Instead of passing, and I'm going to remove that temporarily, instead of passing here a variable that is, for example, my file object, okay? Instead of passing directly the file object to the print writer, what I do is I create another object of class file writer, and I pass to that object the file object, comma, and as second parameter, a true Boolean flag. That means I want to be able to append. Okay, so there is one more intermediary step. You remember when we talked about the nested Russian dolls, right? At the beginning, there is a string, then we wrap the string into a file object, then we wrap the file object into a print writer object. Now we can do some I/O on the file. Well, here there's an extra step. We start with a string that represents the file name, then we wrap a file object around it, then we wrap a file writer, this is a new class, object around it, then we write the print writer around the file writer. And now we're ready to do some I/O, and it's going to append to the file when we do, instead of just overwriting. Okay? So that's given to you, that's explained in the instruction. What else do I need? Well, I need a file. So I decided that my variable name would be file. Why not? All uppercase. I need a file object, right? So I can create my file object like so, and I'm going to find the name of the file that I need to use in the attribute log file. Okay, so let me try to compile this real quick, just so that I make sure that log file is spelled correctly. So log file is spelled correctly, but then, and it's as good as any time to address it. And then the compiler complains about unreported exception named IO exception. It must be caught or declared to be from. So these are the two first strategies that we learned, right? When I want to handle an exception, I can try to do something and catch the exception and get some processing done to handle it, and then that's it. It's like it never happened. Or I can decide to not catch it. If I don't catch it, then I need to declare that my method refroze it. And so that's going to become the problem of whoever called this method. So in this case, I would say something like froze IO exception. Okay. And then the third possibility is I want to both catch it, do something, and then rethrow it or rethrow a different exception to whoever called me. So I would have to declare it also and use the keyword throw also in my catch block. So here, we're going to simplify this a little bit. So what this entails for us here is that we need to try to create our print writer. But then we need to listen carefully in case the print writer is trying to tell us that, for example, the file doesn't exist, or I cannot access it, or I cannot do this or that. So any IO exception. That's what the compiler tells us to do. Okay, and the very minimum thing that I could do is send out print ln the exception, and then system.exit 1. It's really brutal. We're not going to do that, okay? But I'm just saying, if I wanted to just handle the exception, and if anything goes wrong with the print writer, display the error message on the screen and then exit the application, then that's how I would do it. All right. But the instruction tell us that, well, first, this is not the only exception we need to catch. And then they tell us that we should not stop operations because we have a problem with the file. If we have any problem with the file, we should just move on and display our log information on the console. So at this junction, we can go in 3 different directions. So I'm going to choose to rewind a little bit and go back to the beginning of the instruction here and take care of this before we go any further. This here is telling us that this is how we want the information to be written in the file. This is a format we want to use. So the symbol @ okay, followed by the value of the attribute timestamp, followed by a space, followed by the value of input, again, an attribute, followed by a space, followed by an arrow, another space, followed by the value of the attribute result. It's long to describe, but it's very easy to write. So let's do this. String output. Yes, absolutely, Andres. This method is going to dump pretty much the values that are in our attribute into a file as one line that represents a log entry. And you're going to see when I create the string, the format of the log entry is going to make more sense, okay? So it's going to say @ plus this timestamp. So at, I don't know, what are we, like the 2nd of December, 4:03 p.m., okay? So this is going to be followed by the input string. So this is a string that I'm trying to transform. And then an arrow that's going to show me what it was transformed into. So this dot result. Okay. Do we have to use this? No, absolutely, Eric. You don't have to use this in this case. There's no ambiguity. Quite honestly, I don't know why I'm forcing myself to use this like that with you guys. I guess I want to make it so that by default, if every time you want to use an attribute, you write this, then if you get that reflex, even though it's not always necessary, you are going to avoid some type of mistakes. So I guess this is why I've been doing it like that. Can I do it in the try block like this? pw.println, blah, blah, blah. Yes, yeah, absolutely. You could do it instead of, declaring a variable output. You could, inside your try block, when you write actually into the file, you could just use this, this format here, okay? Absolutely, no problem. All right, so I have here what I want to write to the file. I create my file object, okay? Then I create a print writer object. What do I do with a print writer object? Well, I write. So print ln and then output. Okay. So what do I do when I'm done writing to the file? So I told you that the design that we are going for is every time somebody calls this method, okay, every time somebody calls this method, you are going to actually reopen the file, write into it, and then close it again, okay? So because that's our design, that's exactly what we're going to do. So we need to close our file here, okay? All right, so let's see. I have my logic to write into the file. I have my logic to catch an IO exception, except that, yeah, I don't want to just exit the application. I want to do something better. So the instruction tell me if you have any problem with the file, instead of trying to write the log entry inside the file, why don't you write your log entry on the console? There we go. So that I would say this is the only reason, Riley, from which, you know, it's pretty much more convenient to have a string output, okay? But I could also just rewrite here the format, but then I would have my format defined in two different pieces of the code, okay? So minor stuff, but just convenience. So that's it. If I catch any sort of IO exception, and IO exception is an exception class that has also subclasses, right? So if I catch IO exception or any of its subclasses, then I'm going to display on the screen instead of displaying instead of writing inside the file. Okay, so let's try to compile this to see if we forgot something somewhere. Okay, the compiler is happy. Doesn't mean it's going to work. It just means the compiler is happy, right? So we have one more thing to do based on the instruction. The instruction mention IO exception, but they ask us explicitly to handle both IO exception and file not found exception. Okay, so here's the deal. Right now, the code here would work because it so happens that file IO exception is a subclass of IO exception. So if I catch IO exception, I catch also file not found exception. So, but I'm asked to handle it explicitly, so I'm going to do so. Catch file not found exception E. And what am I going to do if I catch that exception? Well, same thing. If I cannot find the file that I'm trying to write to, right, I'm going to just say I'm displaying the log entry to the console instead. And that is okay. That is a way to write it that the compiler is going to be okay with. But what I want to show you, and I already showed that to you, during the lecture, but this is a review session. So what I want to show to you again is what would happen if I messed up the order of those two catch statements. So I'm trying to recompile right now, and the compiler is going to tell me exception file not found has already been caught. So I want you to be familiar. That's why we do this. We take 2 minutes to do this, okay? I want you to remember this error message. If you ever have that in a catch statement, here's the explanation behind it, right? The order in which you put your catch statements is wrong, meaning that one of the classes that you used here, like IO exception, is actually a superclass of one of the class that you use in one of the following catch statement. So here we have only two catch statements, so it's easy. IO exception is a superclass of file not found exception. The superclass should never be before, because if it is before, it's going to catch everything. That's why the compiler says it to you this way. It tells you, by the time I look at catch file not found exception, I realize that if there was a file not found exception raised, you would have caught it here, because IO exception is a superclass of file not found. Yes, Eric, definitely. So in the chat, Eric was mentioning, I remember the hierarchy, the inheritance hierarchy of exception. Is that what we would use as a guideline to know if an exception class is a subclass or superclass of another? Definitely, yeah. So the same way that, you know, exception as runtime exception as a subclass, runtime exception as things like, I think, arithmetic exception and stuff like that. Well, under IO exceptions, you are going to find a bunch of other exception classes, including file not found exception. So the good news about that is that the compiler will yell at you, okay? But the last thing I want is for somebody to get this error message during the exam and be scratching their head for 20 minutes trying to remember, yes, we talked about that sometime during the lecture one time, okay? So yeah, it's likely to happen when you handle exception for IO operations, so it's worth, a bit of a quick refresher here, a memory jolter pretty much. All right, so I put it back the way it was. Compile it again, and it's compiling. So now I'm going to do the same thing that I did to your classmate this morning. We are going to take just a minute here. I'm going to leave that code on the screen, and I would like to see if somebody can tell me what is wrong with this code. Because I make it sound like it's okay, and it's going to work actually. If I try it, it's going to work, but there's something wrong with it. It can stop working at some point. You guys see why? Something with the clause, yep. You do not close the file on the exception. Yep, bingo. You guys zeroed in perfectly. So let's see what can happen. The first thing that can happen is everything is shiny captain. So I execute this, I execute this, I execute this. No exception is raised. I execute this, so I write my log entry into the file. Then I close the file. And you remember what I told you about closing files, right? If you close the file, you flush the output buffer, so you're sure that what you wrote in the file is going to be there on disk. If you don't close the file, if you never close the file, then maybe it's never going to be flushed. Okay, so very important, but we did it. And the catch were not used at all. Okay, perfect. So that's scenario number one. Everything is shiny. Scenario number two, I execute this, I execute the file creation, I execute the print writer, and then I get an exception. So I get an exception. I skip line 290 and line 291, because that's what happens, right? When you get an exception in the middle of a try block, you immediately jump outside the try block. So you skip everything that remains, and you go find yourself a catch clause, right? And you check if the exception that was just raised corresponds to this data type. If it doesn't, you check the next catch clause, you check if it corresponds to this data type. If it does, then you execute the code here, and when you are done, you go back to the next statement after the try-catch block. Okay. If we do that, we never execute the clause. But if I have an exception here, I catch it here, let's say, and I refer another exception. Or what if I have an exception here, but it's not caught in this catch, it's not caught in this catch, then what happens? It ends up bubbling up to whoever called this method. In all those scenarios, the problem is as soon as there is an exception, those two lines are not going to be executed, therefore the clause will not be executed. So I'm going to take this clause and I'm going to put it here. Does that fix the problem? You happy with this version? We need a final closure. Yeah. So the problem with this is, again, there are scenarios where we are never going to execute this line. Okay. So so if we have like an exception that bubbles up, for example, as long as we catch an exception, yes, we are going to execute the code in the catch block, and then we are going to execute what comes after the try. But if an exception is not caught here and is not caught here, then it's going to bubble up, which means we're never going to execute this. We just return back to whoever called us first. So this is why we invented, and I was not part of this work, so let me clarify that. This is why some very smart people invented the finally block. And the finally block is there to guarantee you that if you have no exception, if you have an exception that is caught, if you have an exception that is caught and rethrown, if you have an exception that is ignored and just declared, in all the scenarios, you will end up closing your file. So that's very important. That would be the way to get it done correctly, okay? And as I say that, obviously, the compiler embarrasses me and tells me that I have a syntax error, but that's unrelated to the design. The design is okay. What is not okay is that now that I moved pw.close outside the try block, the problem is that when I declared my print writer right here, I declared it inside the block, the try block. So the scope of that variable, the print writer variable, is inside that block. This is a different block. This is a curly brace block that is completely independent. I cannot see the variable pw in there. So what I need to do instead is, there we go. I'm going to take this. I'm going to remove this. Okay, so I don't declare pw inside the try block anymore. I declare it outside the try block. Okay. Question from Andreas. I know finally always execute, but does it execute every time we pass, iterate the try catch, or only after we have a successful try? No, it executes no matter what happens. So you execute your try block here, okay? Whether you have an exception, you don't have an exception, you catch it, you rethrow it, you declare it, this is going to be executed for sure at the end. So it's not an iteration process, okay, except if you put the whole thing in a loop, but it's a guarantee that you're going to do this. You're going to try to do as many lines of code in the try block as you can. And if one of them fail or if all of them succeed, no matter what, you're going to close at the end. Exactly. No matter what, we run the close at the end. This can all be done by using throws as well. What do you mean this can all be done like the finally close? Instead of try catch. So the instruction asks us to catch those things. So we don't have a choice. But yes, if I didn't want, for example, to, I don't know, let's say I wanted to catch file not found exception. If I get any other type of exception, I don't want to catch them. Okay. So what I could do is I could say that my method is going to catch file not found exception, and then I'm going to declare that it throws IO exception. So that means that if there is an IO exception or any of its subclasses besides file not found exception, then that's not my problem. Somebody else is going to fix that for me, aka whoever called me. Does that address your question? And yes, there is still an error in the finally. We are not dead. We are not done. We're not dead. I hope so. We're not done beating up that problem. So let me undo this modification. Okay. There we go. We are going back to where we were. And if I try to compile this, so this time the compiler is complaining about PW might not have been initialized. So that's why back in COP2512 at the very beginning, I forced you pretty much to always initialize your variable. Because Java is kind enough to tell you when something is not initialized. The C language, for example, is not going to tell you anything. It's just going to use pretty much a random value that's just happened to be there in memory as the value of the variable. And then you are going to have weird behavior for your code. And it's going to take you like a decent amount of time debugging, where that's coming from. So we are just trying to get good habits here. So in this case, print writer PW, I have to assign it to null. Then the Java compiler tells me, you okay, null I can deal with, and that's it. Okay. So now we have a very clean way to do that writing on the file. And like I told you, even like at the beginning of the semester, I told you, that our peak of difficulty would be polymorphism, inheritance, and then things are going to get simpler. What I hope you're going to realize by looking at this example and maybe the next one in the slides is that after you have learned the concept of exception and a lot of the vocabulary and all of that stuff, using exception, especially using them when you do input-output operation, is really straightforward. It's really pragmatic. It's really concrete. Okay, we're not manipulating abstract concept here. We are just actually trying to write to the disk, and if it fails, we're catching the exception. We're doing something about them. For example, write to the console instead of the disk. Okay, and the finally close again makes a lot more sense when you look at something like closing your file. And I really encourage you, by the way, to try to not close your file and try to run this code and see what happens. Or like write a small little program, that just displays. Write a few things in a text file and then try with closing and without closing. Experience for yourself. It's interesting. All right. So this is okay. We can do maybe a little, well, a little, yeah, very little better than this. So let me cut and paste this first. And I'm going to do like I did this morning. I'm going to put the second alternative below. Okay. So what I want to review with you here, kind of refresh your memories about, is we introduce another syntax for the try catch block. Okay, that was try with resources. So this is considered a resource. This is actually a print writer. This is something that can be closed and should be closed. So if anything else, that would be a good definition for a Java resource here. So I'm going to take this, and instead, I'm going to put parentheses here. And in between the parentheses, I'm going to create my print writer. So what you do with that syntax that adds a pair of parentheses between the try and the opening curly brace, okay? What you do is you declare variables here and you assign variables that are going to correspond to resources for typically scanner, print writer, stuff like that for as far as we are concerned. And you create them in that part of the try catch structure so that at the end, you don't even have to close them. You don't even have to have a finally block. So that's another way to write that. And I would say that the trend in programming languages, if you are using Python, you are using something called context managers. The trend is definitely to use this style of programming. Okay, when you open something that can be automatically closed, then let the programming language know that this has to be automatically closed once we are done with this piece of code. And this is the safest way to not forget. Okay, so it's a good habit to take, even though in Java we have other possibilities. It's definitely the way that things are getting set up in modern programming language right now. All right, I'm going to comment out this one because we don't really care. This is just an alternative syntax. Okay, bottom line is we have a version here that works. That's good enough. Let's build it to make sure I don't have any typo remaining lingering right and left. No, we are good. So we are done with this method, and that was actually the one that did all the I/O. So all the I/O in my class is pretty much centralized here in this write log data method. And that's it. That's it for my class string transform. So even though the class string transform doesn't do, it looks like it doesn't do anything useful. What kind of transform is that? You know, it takes an input string and leaves it unchanged. It still does a lot. Okay, I hope you realize that by now. All of that bookkeeping, writing to the log file, managing the log file, the exception, etc., we have it in the class string transform. So now what we can do is when we write one of the subclasses, like for example, class reverse transform extends string transform. Now I don't have to worry anymore about all that log file stuff. Okay, it's done already in the superclass. All I have to do is extend the superclass, connect to it meaningfully. And what I mean by that is, do proper chaining when I override a method. And now I'm going to be able to just focus on what interests me, which is how to transform a string. So the first class we're going to talk about is the one that takes a string and flip it around, okay? Do we still need finally with the print writer statement in the try parentheses? No, we were able to get rid of that. Okay, if you look at the version here, the second version, I have this print writer between the parentheses, and I completely got rid of the finally block because there is, I mean, there are times where you could need a finally block if you had anything else to do. But if the only reason for you to use the finally block is to close the file, it's taken care of. No problem. Okay. How did we initialize PW? So we had to initialize PW here before the try-catch block. So whichever version you go through, you'll have to do it before, otherwise the compiler is going to complain for scope reasons. Okay. Like remember, every time you declare a local variable inside a block of code, like curly braces, that local variable is only usable inside that block of code. So that's the problem that we had at some point with the try-catch syntax that I was trying to write, okay? All right. So reverse transform now. So this is a subclass of string transform. We already started writing a little bit of it. We wrote just the constructor because we wanted the compiler to leave us alone. Okay. If we take a look at the instruction, there's a little bit more needed. So we are going to need a no arg constructor and a one arg constructor that allows you to specify the log name. Okay, so we are going to kind of rework a little bit our constructor situation here, but we won't have a lot to do. Okay, the super and chain with the super class constructor and pass the log, that's already what we need. So no problem there. Now, as far as a no arg constructor, so public reverse transform no argument. So again, what we want to do is we want to chain, appropriately. So here we could do something like this. I'm going to call super, and I'm going to either call super with no arg. I think I do have a constructor with no arg in the super class. Let me double check. Yes. So I could call super with no arg, or I could call super and tell it that the file name is empty string. Okay, that would work as well. I'm pausing here to make sure that it compiles. Okay, and I could also call, without going to the super class, go to another constructor in the same class so that there is only one constructor in my subclass that actually talks to the superclass constructor. It's kind of like funneling all the interaction through this constructor, and I call this constructor with an empty string as well. So we need to make a NOR constructor. Yes, we need to make a NOR constructor. I would say for no other reason that we were instructed to do so. Okay. In practice, NOR constructors that apply default settings like that, for example, by default, the name of the log file is empty string, which means we're not going to use a log file because we cannot open a log file with that name. So instead, we are going to display log information on the console. I would say this is reuseful, and this is a very common thing to do. Okay, you're going to see a lot of people write a bunch of constructors for their class just to allow people to just create an object without specifying anything. If you don't know what the options are, just call the NOR constructor and let it make all the decisions for you. Okay, that's kind of like a generally understood philosophy there in using classes. All right, so we have our constructors. So again, compile. I think I did that already, but let's make sure. There we go, it compiles. Next step, apply and undo. So again, so we had apply and undo in series of transform. These were iterating over all of the transformation object and calling them, each of them in turn, and asking them to apply or undo. Now we had apply and undo method in the string transform class. And they didn't do any transformation really, but they took care of all the bookkeeping. So now we are going to override apply and undo, and we are going to do actual transformation of strings. So in this case, reverse the order of the character. But we are going to reuse what is available in the superclass. So since the other constructor just takes one string for the no arg, all we need is this double quote. Yeah, exactly, Andres. And yeah, we're going to override. So I didn't use the flag, the annotation override here, but I could have. Actually, it would have been a smart thing to do. What I'm interested in is how do I write this apply method here, knowing that I have already the superclass version of apply doing the bookkeeping. Well, I'm going to first say do your bookkeeping. So this is going to trigger the superclass version of apply, which is going to not modify the string, but is going to record, this is an input string, this is a non-modified output, blah, blah, blah. All the information is going to be in place. This is a timestamp. Okay, all of that is taken care of for me by just calling super dot apply s. And then I need to make a change. So I need to assign to the result attribute. So to be consistent with what I've been doing all along, I guess I should be writing this dot result. Okay, even though this is not mandatory. I'm going to say my output. Forget about the output that the superclass set. The superclass said the result was the same as the input. No. I'm going to do something different. So I change the value inside the result. And now I am going to write code that reverses the string. Before I do that, question in the chat. How come when I compile after changing code, it takes longer to compile than if I compile it again without adding more code? Does it save to the cache or something? Um, you know what? Now I would have to dig into that to give you like a definite answer. If we had multiple files, definitely. In this case, it's possible, yeah, it's possible that it just detects that there was no change and just reuses a class file that we already have. Okay, I'm not sure. Next question, is there a difference from calling the super method and just rewriting the code? Yes, there's a big difference in terms of object-oriented programming style. If I was rewriting the code here that is done in the superclass, I would probably, I would say, get fired. It's a bit of an exaggeration, as you may guess, but yeah, people would talk to me if I was working in a company and I would do that. People would talk to me because I introduced redundancy in the code for no good reason. I'm not forced to do it. I just cut and pasted the code from a superclass instead of reusing it. So next time this code from the superclass has to be updated, somebody is going to have to remember my cell phone number and give me a call so that I think about updating my own portion of the class, because nobody else knows that I did that, right? And nobody else cares. So that's the level at which we are. Technically, Java doesn't care if you cut and paste a million times the same fragment of code. The Java compiler will crunch it, put it into a class file, optimize it, and then you're good to go, right? So from the compiler perspective, it's okay. From the programmer perspective, it's definitely, most definitely not okay. Okay? Does that answer your question? So these are things that are a little bit more subjective, right? But these are very, very important, and they are pretty much a standard in industry. So super is just a more efficient way to construct a method. Plus, if we need to add on more like this result equal blah blah, yeah, it's a way to. It's wouldn't say it's more efficient in terms how long does it take to run, but it's more efficient in terms of code organization and maintaining the code. You are pretty much writing good code that is easier to maintain, and because it's easier to maintain, your colleagues are going to read it and have a better time understanding what you are doing. Because they understand it better, if they have to modify it, they're not going to do mistakes in trying to modify code they don't understand, and so on and so forth. So now we're talking about qualities that are like software engineering qualities, right? Again, Java doesn't care, but so it's not going to run faster or slower. It's not going to crash at compilation time or whatever. It's just a matter of writing good code as opposed to writing code that's going to cause everybody who works on it to complain and make a lot more mistakes. Okay. All right. So good question there, but this is like we are bordering to the software engineering class there. Um, and so for the sake of the final, super is needed for full credit. Oh yeah, definitely. If somebody was to not use super here and just rewrite the code that is in the super class, then it would cost a dear chunk of points there, because that's really how to say, that's violating one of the main thing that we learned this semester about avoiding code redundancy. No way to refer to the superclass? Yeah, we do. I'm not sure I understand your remark, Eric. Can you elaborate a bit? That's what we are doing here. We're referring. Okay. All right. So I'm asking the superclass to do its job, pretty much. It does its job. Now I want to add more onto that, just like Andreas was saying, okay? So as soon as the superclass is done doing its job, now I'm going to say, you know what, that result that was set by the superclass to be the same as the input, yeah, I'm going to scratch that. This is an empty string. And I'm setting the ground here to write a loop that's going to iterate over every character in my string, and that is going to concatenate them to the result attribute in reverse order. Okay, so to do that, I'm going to use a good old for loop. That's going to be a quick review of old-fashioned, sorry, index-based looping. So I'm going to say I'm starting with an index I that is going to be s.length -1. So that is the index of the last character in the string s. At the end of every iteration, I'm going to decrement I. So I'm starting from the end of the string, going to the beginning of the string. And I'm going to keep doing that while the index I is greater and equal to 0. Greater or equal to 0. Okay? So starting at the end of the string, going back towards the beginning of the string, looking at every character one by one, and using the index I to access them. How do I access the character at index I in a string? So quick reminder, there is a char@at method in the string class. Again, if you don't remember it, it's okay. You just need to have actually the part of the textbook that shows you all the method in the string class, bookmarked so that you can look it up quickly during the exam. So char@, pass the index. That's going to return the character at index I in the string S. What do I do with this? Result plus equal, I just concatenate. So I concatenate the last character, then I put after it the before the last character, then I put after it the before the last character. You get it, I'm reversing the order of the characters. And when I'm done, let me see, apply, that's it. When I'm done, result is going to actually contain the reversed order string. And that's exactly the transformation that I wanted to apply. How am I going to undo this? Well, I'm going to do the same cut and paste error that I did this morning, just to show you. This is what I did this morning. I was trying to explain to everybody, hey, look, we can actually use the same code, okay? To reverse a string, you flip around the order of the character. To undo that, you reverse it again, okay? So we are going to use the same code. To address your question, Riley, we do not return the result, okay? Please note the undo method returns void, the apply method returns void. All we do is we update the attribute named result. That's what applying the transform means, is you take a string, you put it in input to save the original, and then you transform the string, you put the result in the attribute result, okay? When we call get result is when we are going to ask this object to return to the caller, whatever is in the attribute result. So going back there, this is really natural, to think I'm going to do the same job, except that, well, here we are doing undo. So would it crash actually if I made that mistake? No, it would not crash, but it's definitely bad design. Why would I call apply when I really want to undo? So even if the method apply and undo just happen to do the same job in this particular implementation at this particular point in time, this is not a good reason to call undo instead of apply, okay? So this is one of those mistakes that you make during development. It still compiles, it still runs, and then 6 months later, people are changing the definition of apply, undo, and then suddenly your code starts misbehaving. Instead of applying and undoing, when you try to undo, it applies another time. You see what I mean? So these bugs are the ones that are very, very hard to track down, because it's very possible that that code was written before you even started working for the company, and now that you are modifying their code, you realize that something was not consistent in the previous implementation. So you have to track this down and pretty much tackle one of those, silent code that doesn't say anything at compilation time, doesn't even say anything at runtime. It's way better when a bug makes your code crash cleanly, I would say. Okay, so to avoid that kind of stuff, we can here correct this and use undo instead of apply. Then what about this? This is okay. This is okay. I reverse the order of the character. That's how I undo an operation that was to reverse the order of the character to start off with. Okay. The only thing that bothers me a little bit is, of course, as always, code redundancy. How could I fix this? Well, one of the way to fix this that, again, it would be a bad idea, is to say, oh, yeah, when you try to undo, it's like when you try to apply. You apply again. This looks good because it looks like, I could just implement my undo in one line. Again, it would work. But the fact that I use apply here, to do an undo, this is going to mess with my bookkeeping potentially down the road. So I'm not going to do that either. But what I can do that would be better than what I have right now on the screen is I can look at those two methods that share obviously some code in common. and make a private string reverse method, string s, and that private reverse method is going to integrate my loop. So take this, put it here, right? And instead of this result, I'm going to say I just need a string TMP. I'm going to iterate like I did. I'm going to keep adding to TMP all the characters from the string s, and then at the end, return TMP. So I'm writing an extra little method that the instruction didn't even ask me to write, but I'm doing it because I want to write good code. So I make it private because nobody said that we should expose to whoever used this class, a reverse method. So it's going to be my own little private mess. And I just implement a method that reverses string so that here I can say, for example, reverse s. All right. And then when I look at the over, the undo, again, instead of doing all of this and cut and pasting code that does exactly the same thing, reverse s, and that will work just as well. Okay. So you can use an already defined method in Java, absolutely. And actually, as a matter of fact, if I remember correctly, let's try it. Let's try to compile this first so that I don't write code that is nonsensical. Well, there we go. Reverse bad ID. So what did I do? What did I forget? Reverse private string reverse string s. Well, it's reverse without parameter that doesn't exist. Yeah. So try to build that again. All right, okay, so the code is clean. Now that the code is clean, I can break it again. All right, so what I was going to say is instead of even writing my own version of reverse, if I were smart, I would have looked for a reverse method, maybe in the string class. I don't remember actually if this is reverse like this. Let's try. No, it's not reverse. It's not called reverse. There is a way to reverse string. I mean, this is not something we have to reinvent, but at the moment, I don't remember how you do it with the string class in Java. So I'm just going to go with my own reverse method. But the next iteration would be definitely to get rid of that. And if I can use something that is already written in the JDK instead, then definitely I'm going to use that instead. Okay. All right, making sure that I unbroke the code, but it still compiles. What did I do again? As dot reverse. I thought I just removed that reverse s. There you go. Partially removed it, partially fixed it. There we go. Now it's okay. All right. So we have the apply, we have the reverse for that reverse class. So it implements a reverse transformation on string. What about letter transform? So it's going to be very similar. So we're going to go through it just to wrap up the whole thing. So the idea of letter transform is that you have an attribute named shift, and this is going to be a parameter of your constructor as well, okay? And that attribute named shift is an integer, a small integer generally, and this is what we are going to add to every character in the string. So if your string is a, lowercase a, okay? If I have a shift of 1, then I'm going to look at the first character, it's an A, incremented by 1, it's going to become a B. Look at the second character, it's A, becomes a B. If it was a D, for example, it would become an E. You get the point, okay? So if I have a shift of +1, I increase the letter. If I have a shift of a negative value, I decrease by that many letters. So that allows me to kind of shuffle a little bit around the letters that are in my string based on a specific shift. It's not a particularly smart form of cipher, so I would not even call it a cipher, right? But this is enough to scramble a string and make a transformation on it. So for our goals here, it's a good and legitimate transform. So that shift value needs to be passed in the constructor. So this is why the instruction here tells us you are going to have a no-arg constructor and a to-arg constructor, which allows to specify the log name as well as the so-called character shift value. See below. Okay. All right, so I explained what the shift value is, but I have here one arg constructor. so that's not going to cut it. I need a 0R constructor and a 2R constructor. Why do I have a 1R constructor? Because at the very beginning, I was trying to make the compiler pretty much like accept my code. So until now, it has been serving its purpose. Now I need to implement actually what the requirement asks me to implement. So easy enough, int shift string log, okay, super log, and then what do I do with the shift? Des.shift equal shift, and this time the des. Is mandatory because the parameter has the same name as the attribute. So here we are, okay, call the superclass constructor, give it the log file name, and then manage my own attribute here, the shift private int shift attribute. If I try to compile this, now I broke some code because my main used to create object of this class, like for example here, new letter transform log, and it was happy to use the 1arg constructor. So now I need to use the 2arg constructor instead. And it compiles. Going back to the letter transform class, we have now a 0arg, no arg constructor to write. So public letter transform no args. And as usual, okay, I'm going to try to chain with what I have. So if you don't give me any information at all, I'm going to assume that you want a shift of 1 and that you don't want a log file name, okay? And what we end up doing this morning is we ended up adding 2 more constructors, not because it's required, the instruction didn't ask you to do so, but just because it's, well, it's good practice, and 2, it's also something that's commonly done. Like for example, here I have two potential parameters, right? 2 potential configuration that I can apply to a letter transform object, the file name and the shift value. Here I give 0 configuration information. Here I give the full configuration information. Well, maybe what we want to allow is people to also create letter transform objects, okay, when they know the shift value that they want, but they have no idea that we even use a log file. So in this case, I would say des as the shift value, and then the log file is going to be empty string. And then last possibility, public letter transform. What if you know the log file that you want to use, but you don't care about anything but the default shift? Well, there you go. Des. The shift by default is 1, and the file name is going to be log. So again, we did more than the instruction required us to do, but we end up with 4 constructors that I'm going to leave on the screen here. 4 constructors that cover pretty much all the possibilities in terms of parameterizing that object of class letter transform. So now what do we have left to do? We are almost at the end. We have to implement apply again and undo again in this particular subclass. We have to make sure that they call the superclass and that they change appropriately with it. And then the job we want to do is we want to go over every character in our string and shift the character value based on the attribute shift. So let's take a look at how we're going to get this done. So here's apply, here's undo. First thing I'm going to do so that I don't forget, okay, super.apply s, and here super.undo s. So that way I'm not going to forget about it. Now that I have, sorry, s, input. So I'm going to change input to s actually, so that it's consistent with everything else I've been doing. So once I have that out of the way, now I need to add something more. So I add a feature pretty much, which is applying this weird transformation that I have been describing. So same thing then with the reverse transform. I'm going to start by saying the result is an empty string, and then I'm going to build the result string myself step by step. So we are going to iterate over every character. Again, I'm going to do it with an index. So for I equals 0, I lesser than s dot length, I plus plus. Start at index 0, the beginning, go up to the index of the last character, which is going to be s dot length -1, okay? That's why I use lesser strict here instead of lesser equal. All right, what do I do each time? Well, I'm going to get each character one after the other. So you remember how we did that with this call to the method char add. So this is going to give me the character at index I. Now what I want to do to this character is I want to shift it. So I want to add the value of shift. We can add integers to characters. Those of you who took COP2513 with me, you know that. The others, I'm going to just explain it right now. So you can add to a character a number that just means that A plus 1, character A plus 1 is equal to B. That's it. Java does that automatically. Question in the chat, would setting result to super.result make it so that you don't have to call super.apply? Oh, there's more to it. That's a good thinking, actually, but there's more to it. When I call the apply method, remember, it also do that record log data. So pretty much it's going to do all the bookkeeping. So you are correct that right now, if I didn't care about the bookkeeping, I could just do, result equals super.result, input equals super.input, and so on and so forth, okay? Same for the timestamp. But that would be, one, redundant, and two, I would not reap the benefits of all the bookkeeping that the super class is doing. So when I call apply, super.apply instead, it's going to do all of that, plus the appropriate bookkeeping to prepare me for writing data in the log file, okay? So good question. So back to this loop, I'm going to take each character and I'm going to add the shift value to it, okay? If I only did that, that would be problematic. So I'm going to add one more step. I'm going to say that since I added a number to a character, I want to make sure that the result is going to be looked at as a character so that I may concatenate it to the attribute result. Okay, so this is going to actually apply the conversions, the encoding pretty much to my character. Once I'm done with that, I don't need to return anything. The method returns void. Okay, I did update the attribute this.result, so I could write again this.result here to be consistent with what I've been doing. Question, what is char? So char between parentheses like that, this is a syntax for typecasting. Okay, so we've done typecasting for reference data types, right? And I did just a very, very short reminder on the fact that typecasting exists also for primitive data type. That's what it is. This is typecasting on a primitive data type, as the data type in question is char. Okay, so I make sure that pretty much whatever this expression yields, whatever it evaluates into, is going to be looked at as a value of the data type char. Would leaving that out cause a compilation error? That's a good question. You know what? Let's try it. Assuming that I didn't have over compilation errors in the code data type. No, it doesn't need to a compilation error. So I would have to test it, and actually we can test it at the end if you're curious to see if this is going to actually influence actually the value that is being concatenated, because it could compile, and then instead of concatenating, letters like A, B, C, D, it's going to concatenate things like 1, 2, 3, 4, or actually the ASCII code, okay, transform into strings. So that I would have to double check. I just put this as a precaution every time I need to ensure that the data type is what I think it is. It's either I'm 100% sure of myself, in which case I use the shortcuts, or I convert it explicitly like this. Okay. And yes, if it turns out indeed to be an error, that would be a silent kind of error, the ones that doesn't throw you off at compilation time and doesn't crash at runtime. It just gives you weird result, and then you have to track down where is that weird result coming from, and you spend 30 minutes, a few hours in the debugger. A few hours if everything is okay. Otherwise, I can go a lot longer than that. All right. So this is apply. How am I going to undo this? Well, if I modified every character by adding the shift value to it, if I want to undo this transformation, I just need to subtract the shift value to it. And again, here comes the question, so you cut and paste that loop? Yes, I did. And I'll leave it as an exercise, just like I did this morning, if you guys want to make that a little better, okay, and write like an extra private method that's going to handle this. But I already made my point with the reverse, so I'm okay with skipping on that one. Okay, but yes, ideally that whole logic of character conversion and stuff like that, those index, etc. I would love for not having this repeated twice in my code, and instead have a little, we call them auxiliary function or auxiliary method, helper method that's completely private to this class, and that's going to do that job for me. But right now, if this compiles, we have a version that compiles for our code. So now we're going to be able to get started with the fun stuff, which is testing. So this morning it went really well. The testing worked immediately, and I told my student, don't let that fool you. Okay, it's because the code, we already know pretty much where it's going, or I already know where it's going. Okay, but one thing that we didn't do here that I want you to do in the final is every time you incrementally write code, compile every time. I did that, and also test it every time. And the final will be written in a way so that it's easier for you to test, okay, maybe than this fake exam. Okay. Where do you find your log file? Good question. So this is where I have my source file here, okay, in this directory here. So make sure that you have this browser inside the directory. And then when you run this application, it's going to run in this current working directory, which means that if it creates a new file, it's going to create it also in that folder. Okay. So what happens most of the time is if you double click on a Java file elsewhere, JGraph is going to open, but you are not going to see your file in this panel. So in that case, you just navigate, you check out where your file is, and once you see it here, this is where you're going to see also your text file. pwprintln is accessible instead of pw.write. I'm trying to remember the difference between the two. In our case, println works well because we want to write an entire line, and then we want to go to the next line. If I remember correctly, I think write allows you to do pretty much the equivalent of a print, where you would not necessarily go to the next line. So in our case, that would not, I mean, we could always get it to work like that by adding end of line character at the end, but why make it complicated? Println is going to do that already for us. So println would be just easier to use. All right, so now that I put the warning of, don't wait for everything to be written to debug it in an actual realistic scenario, okay, where you're not just rewriting code that you already wrote several times, let's give it a shot and let's fire up the debugger if we need to. So we run it. So I can see that the text file here already appeared. So at least something is working, right? So the text file here appeared in the folder. If I double click it, there is some log information here, at, followed by the date, okay, the date and time, and then the input string. Remember in the main method, we had this weird input string. Well, this is it. And it tells me that this input string, the first step was to transform it into that string. Then it tells me that the second step was to take that string and transform it into this. And then we took this, transformed it into something else, transformed it into this that's starting to look like English, or at least a human language, and then took this, reversed it, and if you reverse this, you get the final message. Okay? So we are going to troubleshoot why the log file is not popping up for you. Okay? But right now, let me just make sure that the rest of the code here is working, because as soon as we are done, I'm going to upload this code to Canvas so that you guys have the work that we have been doing together this afternoon. So we know that the log file is doing its job. Let's take a look at the console. Undoing series of transform on, and this is the string that I was told at in them. And that's just a reference to a semester where we had a lot of IEs and exams that were like, for let's say, squirrel themed. But this is not so much relevant this semester. Do we need to worry about viewing the log file for final? Well, if you are asked to write a log file to disk, it's a good idea to make sure that the log file that a log file end up being generated, and that the content of that log file is what you expect. Yes, absolutely. Because the graders are going to do that, right? When they look at your code, they're going to run it, they're going to compile it, run it, and they're going to inspect the log file, inspect the output, and then they're going to look at how you implemented this, okay? I cannot guarantee this is what everybody does, but having spent enough time in my life grading also finals and stuff like that, this is generally what I do. I first take the code from the student for a spin to see exactly where we are at, how much is working, how much is not working, and then I look inside the code to see how they achieved those results and what they are missing, okay? And it saves within the same file the class is saved under. So it saves within the same folder that the class is saved under. For example, here I have a folder called, let me go back one level, M6 review sessions, right? Inside that folder, I have my class here, COP2513 final exam review PM2. And then I run this class here in that folder, and it's creating the file there, okay? And it's telling me that I just changed a file here. Do I want to reload it? No, I don't want to reload it. All right, so I hope this was an interesting little exercise. Like I said, this was meant to be more complicated than the final will be. And we can definitely scroll to write log data address. Just give me a second. So it was intended to be more complicated than the final would be, but it was meant to give us pretty much an opportunity and excuse to practice a lot of different things. Now, what I would like to do is, first thing, just like I did this morning, we are going to open the floor for questions. So any question you have about this fake exam, any question you have, like, for example, Riley, I still cannot find my log file. We're going to look into that, okay? Any question you have about the logistic of the final, this is the last time that we're meeting officially for this class, so it's good time to ask anything that you can think of, okay? And then if you have problem with the code, we are going to troubleshoot it. I'm going to stop sharing my screen, and I'm going to share your screen so that I can take a look, but I'll stop the, actually, no, I'm not going to stop the recording just about yet, because once we are done with question, if we have time, I'll try to get you started with the temperature data store example. That second example, temperature data store, I really recommend you look at it only if you need some extra practice with exceptions and file input output, okay? I wanted to have another exercise there focused just on that topic, because this is the last thing that we covered, so this is a thing that we had the last time to practice together, okay? All right, so Riley, I got you on my radar for finding the log file. Let me check real quick in the chat if there are things that I can answer quickly. We will be recording for this review session posted. Yes, the review sessions for last, what was it, Tuesday, right, are already posted for morning and afternoon. The recording for this morning is also posted. The recording for this afternoon will be posted later tonight. It takes about 40 minutes, an hour for Blackboard Collaborate to process the video. Then I upload it to YouTube, and then I put the link in the module. So you will have the video for all 4 review sessions available, and also the source code for all 4 of them, including the solution to the temperature data store problem, okay? Because we are not going to have time to do it entirely together. Like I said, after we are done handling question, if I have time to get you started, that's what we did this morning pretty much, but I want you to have a solution. So there is a solution file that has been already uploaded to Canvas that you can find in the final exam review module, okay? Feels like yesterday we were learning how to do system data print. There's no reason for a sad face. This is cool, actually. So yeah, that's been a very nice journey for me too. I was really happy to teach you guys. So, all right. Anyway, so moving on. If there are no other questions here, and feel free to type them in the chat window as soon as you think of them. I'm going to make Riley a presenter so that he can share his screen with us, and I can take a look at this file and try to figure out where it's hiding. All right, there you go. You are a presenter. Whenever you're ready, go ahead and share your screen. Thanks, Andrew. It's been a great semester too. So since we're like unwinding here, just a word for the final exam. Um, we will be monitoring, the TAs and I will be monitoring Piazza. So if you have last minute question, go to Piazza. This is the best way to get a quick answer. Also, there are more office hours. I have office hours tonight, 7 to 8 p.m. So if you have any other additional question or want to talk one-on-one, please feel free to drop by. And other than that, well, good luck everybody for your final, and I hope you all get a good performance there, and maybe see you in another class. All right. And I'm going to stop the recording here since we're going to do like one-on-one question now.